Okay, add to the stream. All right. So now I hope you can hear my voice. Hear my voice. Okay, hear my voice. Okay, good morning, Muhammad, Arif, Go, Nur, Nabiha. All right. Siti Aisha. Okay, good morning. Okay, good morning all of you. And then let's we continue. Okay, I hope you can hear my voice. Okay, let's we continue to ordinary differential equation. All right. So yes, you are okay. You're hearing my voice. Okay, now okay. Let's we continue to ordinary differential equation. You go to the chapter. You go to chapter 8. All right. You go to chapter 8. Okay. Let's refocus our lecture now. Okay. Right. What is ordinary differential equation? Okay. What is an ordinary differential equation? Right. Ordinary. You can go to the chapter 8, page. Okay. Go to page 173. 173. Okay, I just want to make it clear because I'm giving already this video to you, so I can say that the ordinary differential equation we can divide into two parts. The first is okay, you solve using initial value theorem. What is the initial value theorem? Okay, where the problem of the ordinary have the condition, right? To solve this initial value problem with the condition of initial means that when t is equal to 0, x equal to 0, all right, when the first stage of the problem, we can solve using three methods. The first is Euler method, second is Taylor method, and then the last is Launchpad method, right? Euler method, we solve low order of the differential, okay, differential finite different equation. Taylor series, higher order of the finite different method. And then Launchpad, we have two parts. The first is second order, and then the second is a fourth order of Launchpad method, right? And then the second part of chapter 8 is a boundary value problem, all right? So in this case, you need to use chapter 5, where you are quite expert how to discretize a problem using finite different method. However, their boundary, okay, their problem, there are four types, okay. There are two types. First is a without derivative, which is easy to convert the boundary and initial condition without derivative to the discretization form. And then second is a with derivative. In this case, you need to use center different formula or backward different formula or forward different formula. We are focused so much on the forward different formula. All right. So now sometimes we need to use center different formula. 2 points. Yeah. So you go to the chapter 5, you can go to the forward different formula or center different formula for first derivative. First derivative. Yeah. So there are three conditions. There are four conditions here. Okay, with derivative at the corners, x equal to b, and then with derivative with the both corners, x equal to a and x equal to b. You know, when we have a problem, we have a boundary, x equal to a and x equal to b. So now let's we focus on these four conditions. All right. However, to create a very huge metric, we go to the boundary value for problem with derivative at both corners, x equal to a and x equal to b. All right. So now we go to the first part. It's an initial value theorem, page 173. Go to the e-books or e-notes that I provide in the e-learning. Okay. So now, what is the initial value problem? Right. So initial value problem. Okay, with the problem. Okay, in our case is a first derivative y respect to x equal to fxy. So we set in our mind is fxy is equal to the first derivative y respect to x, where the condition is ya equal to b, meaning that okay, or ya equal to alpha, means that x is between a, okay, and b. We already always put the boundary condition as x naught equal to a and xn equal to b. All right. So the value of the temperature behavior at the early stage x equal to a is alpha. So let's say y is a temperature behavior. All right. So this is an initial value problem where you are given the early stage, early condition at the early corners. All right. So don't forget, we can generate I by using xi equal to a plus ih, where I is between 0, 1, 2, 3 up to n. All right. And then from here, you are given the size of interval for x, okay, which is equal to delta x. Delta x, the formula is a b minus a divided by n. What is n? N is a number of iteration, a number of grid, okay, number of grid involved. All right. So now, what intent in your mind is to solve dy over dx equal to fxy. So we want to get the approximation value of y naught, y1, y2, up to yn, okay, for the first derivative dy over dx equal to fx. All right, so this is not the solution. We want to get the value of y naught, y1, y2, yn. The temperature behavior of y for every point x naught up to xn. Okay, we want to draw the graph, okay, between y1 up to yn. Okay, so set in your mind. So what is the 3-step? I repeat again, the first is what? You need to find the initial, okay, condition where y naught, okay, equal to alpha and x naught equal to a. The second is generate the grid, okay, by using xi equal to a plus ih. What is h? H is a b minus a divided by n. What is n? N is a number of grid, okay, number of iteration involved. All right. And then what is the next step? Is you want to find the value of temperature yi from I equal to 0 to n. So it's set in your mind. All right. So in this case, you need to know how to do the solving the ODE using finite different. Okay. In our case, we assume, okay, to solve this problem using Euler, Taylor, and Ranchkata method. All right. So this is the same as chapter 5. Okay. Not so much different. Okay. You can see here, not so much different. What's different between chapter 8 and chapter 5? Chapter 5 is a basic to discretize the initial value problem or boundary value problem. All right. And then chapter 5, okay, is used to generate the Euler method and Taylor method based on the Taylor series. Okay. Ranchkata is a modification from the Taylor's, and then this is to make the very complex, okay, simulation from Taylor's to be more easiest, we call as a Ranchkata method. All right. So it's very easy, okay. Just extend how you manipulate, okay, to solve initial value problem with the initial condition. All right. So the important is you know how to find yi. Okay, where is yi? Yi is a temperature behavior generated from the Euler or Taylor or Ranchkata, all right, for the grid from x0 up to Sn. All right. So you know already n, you know already h, you know how to create the formula of the Euler method. Euler method is go to the chapter 4 is about the interpolation. We are using Taylor series. So in this case, same. We are using Taylor series order 1. Okay. Taylor series first order we call as a Euler method. What is the formula? Simple. Yi plus 1 equal to yi plus h fxi yi. What is a fxi yi? If you learn from chapter 4, all right. Okay, from chapter 4, okay, you know that the Taylor series develop interpolation, okay, Lagrange interpolation, okay, interpolation divided. So f prime is a dy over dx. Okay, what is a f? F is a dy over dx. In our case, should be f prime, but we assume that f prime is equal to dy over dx, which is equal to fxy. Okay, just this one. Okay, just this one. The different, the way how we want to discretize fxy equal to dy over dx. Okay, what is error? We know already. The error is a difference between the exact solution, the analytical solution, and then the approximation solution that you get from the Euler method. Don't forget dy over dx equal to fxy. All right. So now I can ask you a question about how to find the summation error between Euler method and exact solution. All right. So now, okay, before I go to the example, okay, I want you to focus, okay, 3 point. Okay, what is a 3 point just now? How to solve initial value problem by using y naught equal to, okay, alpha, x naught equal to a, xn equal to b. And then we are using the initial condition y naught equal to alpha to start the Euler, okay, the Euler method. All right. So now how many points is depend on n. N is equal to b minus a divided by h. What is h? Is a size of interval for x exists. All right. So now let's restart. Okay, the process of how to apply Euler method for solving initial value problem. What is the initial value problem? Initial value problem is a first derivative. In our case, is a first derivative of ordinary differential equation. All right, solving using Euler. Euler is come from the first order Taylor series. Okay, solve initial value problem y prime equal to x plus xy, where y naught equal to 1, x naught equal to 0. And then the boundary is between x naught equal to 1 and xn equal to 2. So you know how you transform the problem to the grid form. All right, again, x naught equal to 0, and then y naught is equal to 1. So this one is not 0. This one is a x naught equal to 1. Yeah, x naught equal to 1 means that y naught equal to 1, x naught equal to, in our case, I changed to 0. So x naught equal to 0. Yeah. Okay. So again, how to explain about this question? X naught equal to 0, y naught equal to 1, xn equal to 2. However, they give you h equal to 0.5, means that n is equal to 2 minus 0 divided by 0.5 is equal to 4. So you have 4 points to find y1, y2, y3, y4. Y naught is given as 1 in the question. All right, so you need to remember, okay, the way how I transform this problem to the discretization, all right, process. So the exact solution is given. Why I give you exact solution? Because I want you to compare between the solution from Euler method and then the solution from the exact or analytical solution. You want to find the error, right? So now my question is, find the solution, okay, between the domain 0 and 2. All right, this is the first. So means that you know S naught is 0, Sn S4 is equal to 2, and then xi, okay, and yi, okay, is a domain, okay, of the problem, and n is a b minus a divided by h is equal to 4, right? 2 minus 0 divided by 0.5 is equal to 4. And then start the solution of initial value theorem using Euler method. In our case, we are using Euler method or Taylor's method order 1. Okay, order 1. Very easy. The formula is what? Yi plus 1 equal to yi plus h f x I y I. So remember, the formula of Euler is given in the question. All right, don't worry. All right. So now, okay, what is your intention is to find what is our intention now is to find I is equal to 0, 1, 2, 3, and 4. All right, so this is step. Please remember this step. All right, okay, now I stop sharing. I just want to explain to you when you have the boundary initial value problem and then you need to solve using Euler, you need to go through all these 4 steps. You know how to find n, you know how to find delta x, which is equal to h. You know to find what is x naught. X naught is a 0, y4, x4 is equal to 2. Y naught is equal to 1. So in your mind now, I want to find y1, y2, y3, y4. I need to find 4 points set in your mind using Euler method. All right, so now I want to share with you, okay, the continue of this solution, okay. Okay, let's I share with you, okay, others material. Okay, stop sharing. All right, I start sharing with you for other solution. Okay, let's we go to the solution ordinary differential equation. All right, so now, okay, you can see here, okay, I focus my second, okay, and then, all right, you go to this one. All right, okay, okay, you, okay, so now, I know already the value. I know the value of n is a b minus a divided h. Okay. The question, go to page, don't forget, go to page 174. 174 is a b minus a divided by h. Okay. B is a 2 minus 0 divided by 0.5. I request you to know what is the value a and b, what is a h. Okay, in from the question. All right. So I hope you can draw, okay, the where is the solution in the graph. Okay. So you know that the value of x naught is equal to 0, y naught is equal to 1. All right. So we want to find y1, y2, y3, and y4. Where is the graph? Okay, the graph, it should be parabolic, it's a curve, all right? Should be increasing. The temperature behavior should be increasing, all right? So now, we know that the graph is some sort like this, okay? Means that when the size of grid increase, the temperature behavior also increase, but we want to find the value y1, y2, y3, y4. All right. Y naught is given in the question is equal to 1. Okay. And then the Euler method will be applied to solve this initial value problem. We call this problem as initial value problem because what? Because they are given y naught, yx0 equal to 1. It's given in the question. That's we call as a initial value. Y naught equal to 1 is given in the question. X naught equal to 0. All right. So since they are given this condition, we call the simple problem here as an initial value problem. All right. And then we are going to extend to the boundary value problem. Okay, you need to assume here fxy equal to dy over dx, okay, where fxy now is equal to x plus xy, right? So set in your mind, fxy is what? Is a first derivative y respect to x. So this one set in your mind, right? So now I want to remind you again, okay, come on, okay, what is in your mind? What is in your mind? What is in your mind? That is my question. The first in your mind to solve Euler method, all right, the first thing in your mind to solve Euler method was that you have a three way. detect where is the initial value, what is a h and what is n, and then what is f. F is a dy over the x. In our case, our problem is x plus xy. Or you need to create this problem if there is not this, if you cannot find what is the fxy, right? Fxy should be x dy over the x. Okay, so now let's continue. Okay, now we want to generate the grid. Okay, the grid y1, y2, y3, y4. Means that you need to do the iteration 4 times to find all the value of temperature behavior y1, y2, y3, y4. So the formula is y1 equal to y naught plus hf naught y naught. All right, so just replace y naught is 1 in the question, h is 0.5, x naught is a 0, y naught is equal to 1. All right, so you need to know fx naught y naught is at x naught plus x naught y naught. So it's set in your mind. So just replace and then you can get the answer. Okay, simple formulation, simple to apply. All right, you just replace fx naught y naught as a x naught plus x naught y naught, and then you can get the value is y1 is equal to 1. So there is a straight line. Y naught and y1 is a straight line. All right. So these are weaknesses of the Euler because they're using first order of the Taylor series. Okay. Now we are going to correct this one using Taylor series order 2. All right. Y2 is equal to y1 plus hfx1 y1. All right. So what is y1? Yeah, depends on the previous step. Y1 is 1. H 0.5. x1 is a 0.5, y1 is equal to 1. So you put 0.5 plus 0.5 times 1. So you need to compare with the graph that you draw. All right, but x1 is what? Is because delta h is 0.5, so x1 is 0.5, and then y1 is 1. All right, so the answer is 1.5. So the graph is increased. Just now is a stagnant and then now increased. Y2, okay, the same things you need to apply Y2. Y2 is a Y1 plus H x1 Y1. Now Y3 is a Y2 plus H F x2 Y2. Be careful when you replace F x2 Y2, right? X2 is equal to 1. Okay, go to the graph, all right? X2 is equal to 1. Y2 is equal to 1.5. You replace in the formula of Euler method, all right, is equal to 1.5 plus 0.5, 1 plus 1.5 is 2.5. So the answer, the graph is increase again, all right, from 1.5 to 2.75, all right. So now the last point is Y4. You need to know how to terminate from your iteration. The last point is Y4. Y4 is a y3 plus h f x3 y3. Why you terminate at y4? Because n is 4. N is a b minus a divided by h is 4. Right, so you stop here. All right, y3 is 2.75 plus h 0.5. x3 is a 1.5 plus 1.5 times y3 is 2.75. All right, so the data is a dependent. Okay, if the first y3 wrong answer, so y4 will be wrong answer. You miss the correctness of your answer marks. All right, you miss the marks for correctness, 5.56 the answer. So now if you come back to the graph, okay, the graph is increasing drastically. The temperature behavior increasing drastically depends on the increasing of the grid x0, x1, x2, x3, and x4. All right. So now, what is the difference between you learned before? You learned before, all right, you don't have the initial condition, all right? So you can't find the graph. You need to use interpolation. But here, or least square method. But here, All right, you have initial condition, you have Euler series, you combine, you can generate the graph of the initial value problem solving using using um, Euler methods, using Euler method. All right. So now I can ask you a question here. You can see my question. I ask you how to find the error between Euler method. Euler method, you have data here, and then the exact solution y equal to 2 exponent x squared divided by 2 minus 1. How to get the error? Okay, how to get the error, the difference between. So in this case, you need to draw the table. What is the table? The table between exact solution you generate from yi equal to 2 exponent xi squared, okay, divided by 2 minus 1. Right, so you put i. I is a data generated from 0, 0 0.5, 1.0, 1.25, 2.0, and okay, n is equal to 4, right? So you generate the y0, y1, y2, y3, y4 from the exact solution. You get the answer, right? This answer comes from the exact solution, from the question. All right, you keep this exact solution and then you compare with the Euler method that you get from the same question, all right? And then now you compare in the table. You know I is from 1 to 4, xi from 0 to x0 up to x3, x4, x5. So yi is a Euler already got from the 3-step initial value theorem, apply Euler, all right? And then yi is a exact solution that you generate from the formula, okay, of the table. So you can see here, okay, there are so different exact solution and Euler, very different. 13.7781 for the last point and 5.5626, very different. All right, so we have a problem with the Euler. Why? Because they not converge to the exact solution. Because the error is very huge. If you minus, you can get 8.2156, very huge, very far from the Euler and exact solution at the last point. And then when you do a summation, okay, of the Euler, Euler in your case is a positive, yeah? Okay, the error is positive. I stop again, okay, here. Okay, you have to know, okay, you have to know the summation error that you learn from the chapter 4 on the least square method is summation xi squared. Am I right? So in our case, I put absolute value. The absolute value between the exact solution and approximation solution, okay, there is a error, absolute error, summation absolute error. All right, you can see the summation absolute error is big because we have a problem, Euler at the last point. All right, so this is weaknesses of the Euler. Okay, why? Because Euler using Taylor's method order 1, okay, first order. So that is weaknesses. They put the transcation error for order 2, order 3, they put as 0. So that's why the error is very huge. All right. So now, okay, okay, now let's you find, okay, where you want to find the solution here. Go to page, okay, come on, you go to page, okay, initial value theorem, Euler method, okay, which page, come on, go to page Euler method, okay, you go page 178, all right, go to page 178. Where is the 178? Here. All right, you can see that. Okay, okay, all right. Okay, I have ebooks also with you. All right, so now let's continue. Okay, let's continue. Share screen again. Okay, go to the video too. All right, and then this is a solution. Okay, how to get the error, and you compare with the you want to reduce the error by comparing between the Euler and Taylor series. Okay, now I want to correct the data that you get from exponent I summation from I equal to 0 up to n. I want to reduce this. Okay, can you find go to page 178. Okay, go to page go to page 178. Okay, can you find, my question is, can you find the summation E? Alright, can you find the summation E? So I'm waiting your answer. Okay, go to page 178, the example, and I'm waiting you to find the summation of the error. How much the summation of error, because I want to reduce this summation using Euler. Alright, so my question is how to reduce the error. So in our problem here, let's go to the Taylor series. Okay, let's go to the Taylor series. All right. So now, okay, let's we go to Taylor series. Okay, where is the Taylor series? Okay, here. I'm stop sharing. Okay, I want to go to Taylor series. Okay, let's learn. Okay, since I'm still waiting your answer. All right. So I'm still waiting your answer to get the summation EI. Okay, at page 178. I want to go to Taylor series. Okay, so now stop sharing. Okay, I'm stop sharing. I want to share with you the Taylor series. Okay, where is the Taylor series? All right. Taylor series. All right. Now I'm going to Taylor series. All right. I'm stop sharing. I want to focus my lecture on the Taylor series. Okay, what is a Taylor series? Okay, all right. So now because of Euler is just focus on the first order of Taylor series, yi plus 1 equal to yi equal plus h f x I y I, where f is a first derivative y respect to x. Now I want to extend the order to the second order, okay, fourth order, three order using Taylor series. Okay, so since I know the Taylor series, I can correct, okay, the example before this by improve, okay, by enhance, by increasing the order of the um, derivative here. So yi plus 1 equal to yi plus h yi prime plus h divided by 2 yi. So in this case, where is the Taylor series? I put in the simplest, I cut again, I cut, all right, I stop. This is a Euler method where y prime is a fxy. What is a y prime? Y prime is equal to fxy. This is a Euler method. Okay, Euler is very simple and the error is very weak. Now I extend to higher order. Y squared divided by 2 factorial, y prime prime I plus h power 3 divided by 3 factorial, y prime prime prime, okay, third order derivative, plus, okay, h power 4 divided by 4 factorial, y prime 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 prime. All right, so meaning that if I extend the series, okay, the series is not weird for you. It is common. We learn in chapter 4. All right. We also learn in chapter 3 about this Taylor series. Okay, because this is very basic to do the formulation of the finite different method in chapter 5. Still remember, kan? All right. So we are applying the basic Taylor series to solve the initial value problem. All right. So this is Taylor series. We want to use this Taylor series to solve initial value problem using Launchpad method. We want to solve initial value theorem using the Launchpad method, and then using, okay, higher order of Launchpad method, order 4 or order 2. So I can write here hk plus 1 divided k plus 1 factorial. All right, yk, k is a derivative, the order. So once you higher the order, the result is much more accurate. All right, you can solve initial value problem, boundary value problem with a higher, higher order of Taylor method, Taylor series. So in this case, you have you can solve order k plus one, and then but because we want to set your question in 20 minutes, so we are focus you Taylor series order 2, Taylor series order 3, for example. We not go for the higher order because we want you to solve the initial value problem in 20 minutes. So you can get yi plus 1 equal to yi plus h, yi prime plus h squared divided by 2 factorial, yi prime prime plus h power 3 divided by 3 factorial, y prime prime prime. Okay, so this is the way I want to make sure that you can solve the problem in the order 2 or order 3, right? So that I mentioned before, Euler method is a Taylor series, first order. Taylor series with a first order, until yi plus h yi prime. What we call is a first order Taylor series we call as a Euler method. It's a basic method. Range-kata is a order 2 is a Taylor series order 2. Range-kata order 4 is a Taylor series order 4. So why we learn Range-kata? Because the way we write this formula is simple. The way we do a simulation is based on the step, step by step, time step. We call it depend on the step. All right. Taylor is not based on the time step. All right. It's not based on the time step. All right. So now, so let's we continue to we stop sharing. We want you to focus. What is the we back again. The Taylor series. Now what is a Taylor series? Taylor series is a formula with the k order of the Taylors. We can use Taylor series to solve initial value problem, to correct the Euler, to correct the error, summation error between the y and yxi, between the exact solution and the solution from the Taylors. Right. So now, we want you to focus now. Let's we go to the process to correct the Euler method. How to correct the process of Euler method. All right, so introduction. All right, so now let's we go to the Taylor series. Taylor series. Why? Because we want to correct the Euler method. So now nobody want to answer my question, how to reduce the error, and go to page 178. How much the summation of the error? I'm waiting you to find the summation error. I'm waiting you to find the summation error. Since I'm waiting you here, I want you to go to the Taylor series. Taylor series. You can see that I can reduce this error by using the Taylor series. And then the Taylor series is the computational is very high because the order is very high. The time also, the way you do summation also very time consuming. So now we come back to the same question. We want to use the same question, solving the initial value problem, y prime equal to x plus xy, all right, where the y naught is equal to 1, x naught equal to 0, and xn is equal to 2. N is equal to 4 because b minus a divided by h, 4 minus 0 divided by 0.5 is 4. We want to use, the Taylor series order 3 to correct the Euler method, to increase the accuracy of Euler method. All right. How to do that? Because Taylor series okay, using the formula of Taylor, okay, at the order 3. So this is a different. Okay, since we have the initial condition exact solution, so we can find the error and we can show that the Taylor series order 3 is better than Euler method. Okay. Okay, our aim is to, as usual, is to draw the graph of y, not y prime, y is a temperature behavior when x is moving from x0, x1, x2, x3, x4, all right? N is 4, okay, and b is, h is a 0.5. All right, so the graph should be in the curve, right? But we want to, because we have an exact solution, we can find the error. We can find the error between the Taylor series order 3 and the exact solution. All right. So the same terminology, the same process, we're going to apply, okay, the same graph, you need to draw, okay, the same location y1, y2, y3, y4, and the same graph, okay, to solve using the Taylor series, In your case, please set in your mind y prime is a x plus xy. Y prime prime is what? Is a dy over dx, is a Bezier x, okay, differential x respect to x is equal to 1. And then you need to be careful here. Xy. When you do a differentiate xy respect to x, okay, you need to do differentiation part by part. You differentiate x, you can get 1. And then you differentiate y, okay, you not differentiate y, you put y. 1 times y plus you ignore x, okay, you maintain the value of x, but you differentiate y, you can get y prime. So be careful when you do the higher order derivative. All right, this one is a y prime prime is a 1 plus, okay, do differentiate part by part, okay, y plus x y prime. And then y prime prime also you can refer from dy prime prime over dx. There's, okay, the second, the last part, okay, is a y prime prime. How to be that? dy1 over dx equal to 0. dy over dx is a y prime plus 1 plus y prime, okay, dx over dx is 1, y prime plus maintain x, okay, and dy prime prime. All right, so now replace what is a y prime. Y prime is a x plus xy. What is a y prime prime? Y prime is at this previous step, 1 plus 1 plus xy prime. You replace. So you can see y prime prime prime, okay, higher order 3 for y is become, okay, complex. Okay, because there is a y prime and y prime prime for simulate the value of y prime and prime. So these are weaknesses of the Taylors. What is the weaknesses of the Taylors? I stop here. Okay, I want you to focus. Okay, you focus. Okay, what is the weaknesses of the Taylor here? Okay, because you need to do third order derivative. You need to do how much? Okay, third order derivative. Y prime prime, y prime prime. Because you are using Taylor series order 3. Because you are using Taylor series order 3. So you see your friend said that, wow, the error is very high. 11.6896, very high. So now let's reduce the error. Okay, I'm using Taylor series now. I want you to do a Taylor series. However, the weaknesses of Taylor series is a order 3. You need to find y prime prime prime. You need to find y prime 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 prime. These are weaknesses of order 3. All right. So now, okay, and then now, come on, I do a differentiate respect to the higher order kan. Tengok kan, ya Allah, y prime plus xy prime prime. Alright, so I already remind you, xy prime means that what? You do part by part, dx over dx equal to 1. Alright, and then y prime, you leave it y prime plus, All right, you leave it x, okay, and then you differentiate y prime, you will get y prime prime. So be careful this one. I'm always remind you, this is a calculus, easy to understand, all right, to replace y prime prime. Okay, so now, come on, we replace y prime already, okay, from the first step, y prime prime from the previous step. All right, so when you put in, you will get yi plus 1. This one is a Taylor series, Taylor method order tree. Very, very complex because you need to replace y prime, all right? So come on, the Taylor series order tree is like this: y prime plus h y prime plus h divided by 2, y prime prime plus h power 3 divided by 3 factorial y prime prime. Come on, we need to insert the value, all right? And then you are also given, okay, you also given in the question x not equal to 0, y not equal to 1. Euler also the same, use the same initial condition, right? So now we need to create when I equal to 1, I equal to 2, I equal to 3, I equal to 4, all right? Okay, I equal to 1, I equal to 2, and I equal to 3, because to get I equal to 3, you can get y4, all right? So please insert y1 equal to y naught plus h y prime plus h squared divided by 2 factorial y prime prime naught plus h squared power 3 divided by 3 factorial y prime prime. Okay, come on, you insert the value y prime prime 2 you get from the previous step. Okay, you replace y naught is what? Is 1. Y naught prime, you use equation number 1, number 2, and number 3. You use equation number 1, number 2, and number 3. Okay, replace, okay, for x naught is equal to 0. Okay, y naught prime, okay, y naught prime is equal to x naught plus x naught y naught is equal to 0. All right, okay, y prime prime is 1 plus y naught plus x naught y naught. Y naught, okay, you can get the value 1 plus 1 is equal to 2. So you need to do step by step, okay? Replace x naught equal to 0, y naught equal to 1, okay, for every step. How many steps is now? Y prime, y prime prime, y prime prime prime, all right? So what to do? You need to, you can also insert all the equation in the y1, okay? Also can, okay, you can insert all the value 1 to 3 to star equation, you can do that, okay, or you need to do one by one like this. You can get y naught prime prime is equal to 2, y naught prime 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 is equal to, okay, 2 minus, okay, it's depend on the data previous, 0 plus 0 plus y prime prime is equal to 2. So the answer is 0. The answer is 0. All right, so now insert in the star, okay, after getting all the value of y prime, prime prime, and prime prime when x equal to 0, put in the star. All right, so you will get the value of y1. Y1 is very not easy to use because you are apply Taylor's, so y1 is a 1.125. Euler, you can get y1 is equal to 1. So you can see Euler, the graph is a straight and then increase. But here you can see Taylor series, the graph is increasing from 1 to 1.125. All right. So the same step, okay, you are going to repeat again to find the value y2. How to get y2 using Taylor series order tree? You need to know when I equal to 1, x1 equal to 0.5, y1 is equal to 1.125, you can generate y2. So it's same, okay, because you need to go through to find I equal to 0, I equal to 1, I equal to 2, and I equal to 3. All right, so now I'm stopped here. Okay, I want to focus. Okay, what you want to focus? What in your mind? Okay, okay. How complex? Okay, how complex the Taylor series? Taylor series. Right. So this problem. How the complex? Continue again. Right. So now I just want to express here, okay, how complex the Taylor series, okay, because you need to go to I equal to 0, I equal to 1, I equal to 2, I equal to 3. For every step, you need to find yi prime, yi prime prime, yi prime prime prime, and then insert to the formula of Taylor series 3. So how many calculation you need to do? 1, 2, 3, 4. 4 calculation times 3 grid. So you have 12 step to go through. 12 step to go through. All right. So now, how complex? Because the Taylor series depends on the higher order. Okay, higher order of the calculation. So that is the weaknesses. All right. So of the Taylor series. So let's be focused. Okay, we focus to go through all the 12 steps. Wow. All right. So I equal to 1 goes the same step. I equal to 1, x1 is equal 0.5, y1 is 1.125. All right. So you need to find y1 prime, y2 prime prime, sorry, y1 prime, y1 prime prime, and y1 prime prime prime. All right, to get y2. Y2 the same. You are using the star equation here, the star equation, the Taylor series order tree. All right, so y1 prime, okay, is a okay, y1 prime. Okay, you use the formula. Okay, use formula at the previous step. There is a 3 formula there. Y1 prime is a 1 plus y1 plus x1 y1 prime. Right? Y1 prime is okay. You need to find y1 prime first. All right. So okay, you can see one. This one is y prime prime. This one is a formula of y prime prime is equal to y plus y1 plus x1 y1 prime. All right. So okay, okay. The problem here is okay, you can see here, okay, prime, y1 prime is a x1, go to formula, x1 plus x1 y1, okay, put the value, because you get the value from the previous step, so y1 prime is, okay, plus use your calculator, very simple, however, the step is make the calculation complex, okay, or all right, and then now we go to the y1 prime prime. All right, y1 prime prime is a 1 plus y1 plus x1 y1 prime. Right, put all the value, you get what is the value of y1 prime from the previous 1.125. Now the third equation is a y1 prime prime prime. Is a 2y1 prime plus x. Use the formula 1, 2, 3 above. x1 y1 prime prime. So you will get the answer, okay, by insert all the value from the previous step. Okay, 3.6563. All right. So now you get y2. What is a y2? Okay, as the star equation, use a star equation. You just replace y1 1.25 y1 prime, okay, is a 1.125, y1 prime prime is a 2.8125, and y1 prime prime, okay, 3.6563. So use your calculator. Where is your calculator? Okay, in this case, okay, where is your calculator? Okay, I just want to remind you, okay, you need to use the calculator to find the three value y1 prime, y1 prime prime, y1 prime prime prime. You can set in the calculator to make it more fastest, okay, to make it more fastest. All right. So you can see here the value of I, okay, when I is equal to 2. All right. You can get y3. The same step, you need to know what is y2, y2 prime, y2 prime prime, and y2 prime prime to generate y3. What is y3? The same formula at the start as a y2 plus hy2 prime plus h2 divided by 2 factorial y2 prime prime plus h power 3 divided by 3 factorial y2 prime prime. Alright, so the same things, okay, you also need to use to find the value of y4, can? Okay, y4 when I equal to 3. So you are going to stop here. When I equal to 3, okay, you are going to get y4. You stop your calculation here. So that's why, okay, I told you you have 12 calculation. When I equal to 3, you can get y4. Okay, the same things you need to find y3, okay, y3 factorial, and y3 prime, y3 prime prime, and y3 prime prime prime. Right, so you can get y4. So this is a step that you need to repeat and repeat. All right, the iteration repeat based on the you generate the grid, a new grid, y3, y4, y2, and y1. So you can get the answer. Okay, the y4 now is 12.7806 is merged to the AZ solution. AZ solution is a 8 point something just now from Euler. All right, so when you do the AZ solution, you compare with the AZ solution, you can see that the Taylor series, okay, is much more better. All right, so now, okay, if you can go to page, we go to page 100, okay. Okay, don't say that Dr. Norma teach very fast. I give you the video, so I just want to make okay, conclude what you learn. All right, so you can see here. Okay, where is the why is it's moving here? Okay, I want to stop here. All right. So if you go to page, we go to page 100. 83. Okay, 183. I focus here. Okay, 183. Right. At 183, you can see the result for Taylor series order 3. All right. So now my question is, okay, the same. Okay, go to page 183. Right. Can you find? So this is my question. Can you find the summation of E? All right, so how much? Okay, just now you get the error is 11. But now my question is, can you find, okay, by using Taylor series order 3, can you find the summation of error? You can reduce or not. Okay, you can reduce or not. All right, so develop a table again and then find the summation of the error. All right, so you can see that the Taylor Euler is much more biggest compared to the Taylor's. Okay, okay, much more weak, very weak compared to the tennis. Okay, okay, now, okay, okay. So now we know that the best method is what? Is a Taylor series. However, the process, you can see the process here is very what? Is a very complex. You can see here. is a very complex. You need to do 12 steps. Okay, I want you to focus here. You need to do 12 steps. So how? Because you need to know what is a y prime, y prime prime, y prime prime prime. How to reduce this complexity? Okay, okay, how to reduce? Okay, we go to the Ranskata method. All right, we go to the Ranskata method. So the level of accuracy Ranskata and Taylor series almost similar. All right, because they're using higher order of the Taylor series. All right. So now, if I can share with you the Ranskata, okay, because Ranskata is very fast, very simple. I just want to focus on order two. Okay, I don't want to focus order four because I think you cannot spend 20 minutes to answer Rajkata order four. I go to the order two, and then for order four you can do by your own because we provide you e-notes, ebook, and digital video, right? So it's really support your self-determined learning. It's really support your self-determined learning plus the uh, uh, exercise at the Padlet and the e-learning. Okay, okay. So now, some of you ask me a question. Okay, before that, I since I'm waiting you this answer. Okay, I just want to okay remind you here. Okay, if I can go to okay to here. Okay, if I can share my screen to here, stop sharing. I'm sharing my screen to this screen. Okay, if I can go to this screen. All right. All right. I go to the screen. Yes, I success to call my screen here. All right. So you can see here. Okay. Many questions about what is the question to answer. Okay, about the boundary value problem, initial value problem. All right, that you have. So you can go to the my Google form. Okay, this is a question you need to answer, all right, using the boundary value problem. Okay, because there is some question. Okay, and then the Euler, I just focus to the actually Padlet. I'm going to give you a Padlet okay, for the question, or you refer to the e-learning. Right? Okay, now okay, I stop sharing here. Okay, I want to focus on this. Okay, Rajkata. Okay, all right, so I go to the ranch kata, stop sharing. Okay, go to the ranch kata. Where is the ranch kata? All right here. All right. So I'm going to give these notes, okay, at the e-learning. Don't worry, okay. However, I want you to focus on ranch kata. Let's go to the ranch kata method. Why we learn ranch kata method? Yeah. Okay, branch kata method is a higher order of the Taylor series, but the way how they represent the Taylor series is much more simple. All right, the Taylor series method or Taylor method is not practical because you need to find why not prime, why not prime prime, why not prime prime prime. All right, depends on the order. So they involve the step of derivative. Okay, in range kata, we put the step of derivative in the very good manner. All right. So we propose range kata. Okay, why? Because we want to reduce the complexity, the simulation complexity to the step order. All right, to step by step process. Okay, the range kata order two. Okay, we call as Han method and midpoint method. Okay, what's different Hans and midpoint is depend on the acceleration parameter. All right. In this case, okay, okay, I'm stop here. Rajkata order 2, Han method is one of the good, okay, good example. You can solve this problem in 20 minutes. All right. Okay, Rajkata order 2 based on Han method, you can solve in 20 minutes. Okay. Rajkata order 4, okay, is much involved, okay, uh, 4 step. So I'm worried you cannot answer in the 20 minutes. So the formula for Raj Kata order 2, okay, Hans method, okay, is depend on the R. Okay, depend on R. The basic Raj Kata order 2 is a yi plus 1 equal to yi plus C1 K1 plus C2 K2. What is a C1? C1 is a 1 over minus 1 over 2R. What is C2? What C2 is a C2 is a 1 over 2R. Okay, what is R? R is a acceleration parameter. What is R? R is a weighted parameter. All right, to make it more fastest converge to the exact solution, to the approximation solution. All right, so we play with R. R if Han R equal to 1. If you want to use midpoint method, R is equal to half. All right. What is K? K is a HFXIYI. What is K2? HFXI plus R HYI plus RK1. So you can see here, this method is depend on the previous step. So be careful. You need to find a very clear C1, C2. You need to find a very good solution for K1 because K2 is depend on R and depend on K1. Okay, so this is the weaknesses of the lunch kata because it's two, we call as a multi-step. There are two steps to solve a lunch kata method, right? So now, if I want to solve, okay, using Han method, okay, all right, so I need to replace R as equal to 1. For fourth order derivative, the formula is complex because involve 3 steps. You need to find 4 steps: K1, K2, K3, K4. Right? What is there is no R because we put R as equal to 1. So K1 is a H F X I Y I. What is K2? K2 is H F X I plus H divided by 2 yi plus k1 divided by 2. What is k3? K3 is equal to hfxi plus h divided by 2 yi plus k2 divided by 2. What is k4? K4 is a hfxi plus h and then yi plus k3. You can see here, wow, okay, you can see here, come on, it's very complex for fourth order derivatives. It's much more complex compared to the Taylor series order tree. Kan? Alright, because how many steps you need to go through? 4 steps. You need to find K1, K2, K3, K4 before you get yi plus 1. What is yi plus 1? Y0, y1, y2, y3, y4. What is y0? Y0 is a given in the question. Alright, so oh wow, I'm not sure you can solve in 20 minutes. So that's why I want you to solve the problem of initial value problem using lunch kata order 2. Okay, let's we go to the lunch kata order 2. Alright. Okay. Lunch kata order 2. Okay. Is involve low computational complexity, low cost, okay, on the time consuming, okay, for you to complete. All right. So when we go to the Rajkata order, second order, right, we are using this example. We want to solve initial value theorem. The same question: y prime equal to x plus xy, y not equal to 1, x not equal to 0, x4 equal to 2, h is equal to 0.5. This is a similar question. We want to use Han method. I told you Han method, R is equal to 1. Alright, so you replace second order Rajkata method. Okay, and then the result that you get from Rajkata order, second order, you compare with the exact solution. Alright, the exact solution is y equal to 2 times exponent x squared divided by 2 minus 1. Alright, so now, okay, the way to solve using Rajkata order 2, or we call as Han method, is a find what is y prime. I told you y prime is equal to fxy. Alright, where is the initial condition? I told you y not equal to 1, x not equal to 0. And then what is the formula Han's method? I told you it's a Rajkata order 2, r is equal to 1. Alright, so now find the value of y. Y in our case is a y1, y2, y3, y4, right? For the solution of y prime equal to x plus xy, all right? So in this case, you have to know you want to find the value of y, not the y prime, yeah? Y prime. So now, okay, I go to formula again. Okay, go to the formula. Range kata order 2 is a hand method where R is equal to 1. All right. So very simple. When you choose R equal to 1, you can get straightforward the repeat formula for range kata order 2. Okay. And then if R equal to half is a midpoint method. So we can ask you a question whether R equal to 1 or R equal to half. Yeah. Formula is given in the question. All right. Don't worry. Okay. So now let's refocus to the branch kata. Okay, this example. Okay, we want to solve this problem, okay, using hand method. We have four steps. All right, we want to draw this graph, y0, y1, y2, y3, y4. We know what is n. N is a b minus a divided by h is equal to 4. We know h 0.5. And then now we want to apply Hans method. The first is, okay, we generate I equal to 0. Second, I equal to 1, I equal to 2, and I equal to 3. When I equal to 0, y1 is equal to y0 plus 1 divided by 2 k1 plus k2. Okay, there is no c1, c2 because r is equal to 1. So this is the formula of Hahn method. Okay, from where you get the Hahn method, the formula. All right, so where you go to the textbook again. Come on, you go to the textbook. Okay, go to the textbook. Where is the textbook page? Branch kata. Okay, branch kata. Come on, we go to branch kata. Hahn method. Hahn method. Okay, order 2. Please go to page 185. 185. All right. As you can see here, 185. All right. The formula of Hahn method when R is equal to 1. Congratulations. You can see the Siti No Nadiha. Okay. They said that the Taylor series is the error is only 1.2916. However, if you use Euler method, the error is 11.68. All right. So it means that Taylor method is better. So now let's we continue with the branch kata, order 2 or Hahn method. Right. So now let's we go and focus the branch kata, order 2. Alright, so now in this case, okay, you set in your mind y prime is equal to fxi yi equal to xi plus siyi. Alright, and then k1 is so you need remember what is k1? K1 is h at fx not y not. Use the formula. Okay, it's a 0.5. X naught is 0 from the question, Y naught is 1 from the question. And then use the formula F equal to Si plus Siyi. Put the formula Xi is 0 plus 0 times 1 is 0. So K1 is 0. K2 is a H Fx naught plus H Y naught plus K1. Be careful. What is H? 0.5. What is X naught? 0 is 0. What is H? 0.5. What is Y naught? Y naught is a 1. K1 you get from the previous step is equal to 0. So you just replace the value. You can get 0.5, 0 plus 0.5, comma, Y naught is 1 plus 0. You will get 0.5 F 0.5, comma 1. So use the formula Si plus Siyi, apply again Si plus Siyi as your function F, right? So insert in the formula, you will get 0.5, okay, times 0.5 plus 0.5 times 1. You get y1 is use the the formula, star formula, y naught plus 1 over 2 k1 plus k2 is equal to 1.25. All right, so the step, I know it's complex. It's complex. You can see the step is still complex, but it's simple. And then you reduce the computational cost from the Taylor series order tree. It's a step. Okay, what we call Launchpad is a multi-step. There are two steps you need to go through, K1 and K2. Okay, in the Taylor series order tree, you need to go through three steps. Okay, y prime, y prime prime, and y prime prime. But here you need to go through two steps. So you reduce the computational cost, and then the result is, we hope that it's better than the Taylor series. Okay, Taylor series, order 2 or order 3. We try, right? So now we continue to find y2. Okay, we want to find y2 when I equal to 1, x1 equal to 0.5 because the question is given. Okay, f equal to si plus si yi. We need to find y2. This one is y2 should be. Y2 is a y1 plus 1 over 2 k1 plus k2. Alright. K1, the same formula, is a hfx1 y1. Replace, okay, x1 is 0.5 and then y1 is 1.25. You will get 0.5625. K2, again, the same process is a hfxi plus h and yi plus k1. Right? So you replace the value and then y1 you got from the previous step, k1 you get from the previous step, and then you can get k2. Right? So now you can get y2 is equal to y1 plus 1 over 2 k1 plus k2 that you get from the previous step. Please correct, yeah, this one is a y1, y2. All right. So now, okay, you can get y2 is equal to, should be greater from y1. Okay, so y2 is equal to 2.2344. Is greater, much more greater from the y1. So now continue to y is equal to 2, x2 is 1.0. You get y3, right? y3 is what? y2 plus 1 over 2 k1 plus k2. Right, so you need to find what is k1 and what is k2 to find y3. All right, so this is a process you need to repeat, okay, until you get all the value of y, y0, y3, y2, y1. Right, so you get y3 is a you just apply fxy equal to xiyi, yeah? Si plus siyi. So, okay, y3, okay, by using the formula from the branch kata order 2, okay, y3 is, the value is given in this simulation is a y2 plus 1 over 2 k1 plus k2. Right, so now continue again. The last point, when I equal to 3, you can get y4, right? When I equal to 3, you can get y4. Okay, k1 is equal to the same formula of the Rajkata, Han method, order 2, okay, 0.5 fx3 y3. K2 is 0.5 fx3 plus 0 h plus comma y3 plus k1. So you can get y4 is a 4.8, come on, 4.8223 is a, this one is a y3, y4 is a 4.8623 plus 1 over 2 k1 plus k2 is a 12.1902. It's almost similar, a push, okay, converge to the exact solution. Kan? Exact solution is a 8 point something, but this one is 12, right? So you can find the error. If you can find the error between the Rajkata order 2 Han method, and then the exact solution. Alright? So to do the comparison, what should you do? You draw the the table. Okay, you need to find the value for exact solution, which is you get from the Taylor series and Euler series before, right? So I, X, Y, I from the Rajkata method or Hans method, and then the YXI is a exact solution, and then the last is a approximation between the exact solution and Han method or Rajkata order 2. All right, so from here, okay, you can see, okay, um, find me the error. Find me the error between exact solution and approximation solution. What is the error? Is an absolute, okay, for every I, okay, yi minus yxi. Yxi is a exact solution. Yi is a Han method. Han method. All right. So E is a summation of the I from 0 to 4, and then you can get the answer. Come on, I want you to find the answer. Come on, can you find the answer? Okay, take time to find the answer, all right? To find the range kata order two uh, order or Hans method, all right? To get the E. I'm waiting for you. All right. So actually, you can also solve this problem, okay, using range kata order four. Okay. So use yourself determined learning in page 191. So now I said to you, go to page 100. Let's we go to the Rajkata order 2. Which page? Rajkata order 2, Han method. Okay. You go to page 196. Go to page 196 and then can you same, okay, can you find same question? The summation error, okay, summation error of E using this one is a range kata order 2. All right, or we call as a Han method. We call as a Han method. All right. So can you answer my question here? Is can you get the error whether very good, okay, very bad, or approximation solution? Okay, you can find, okay, whether Han method can correct the Taylor method. We don't know. Okay, and then you can also find for me. Okay, Raj Kata order 4 is much more champion. All right, but I'm not sure I can give this question in edit. Okay, I'm not sure because you spend the time, okay, for the higher order Rajkata or higher order Taylor series. All right. Okay. Any question? I'm looking for any question. If you have no question, all right. I want to share with you. Okay, in e-learning. Okay, let's we go to the e-learning. All right. Okay, I'm on my e-learning. Okay, what you get in the at the e-learning after this. Okay, I share with you. Come on, if I can share with you the screen to the e-learning. All right, go to the e-learning. Okay, on your e-learning. Okay, where is my e-learning? Okay. All right, this is my e-learning. Okay. You can see here, okay, e-learning, you can see here, okay, okay. The e-learning, I already, okay, sent to you many material. For example, test 2, we finished already test 2. We already finished chapter 7, okay, why we need to learn eigenvalue, how to find the eigenvalue, the three eigenvalue, right? And then we go to the ordinary differential equation. I already sent to you the Taylor series, Ranch-Kata method, all right? And then boundary value theorem, okay, I already sent to you. And then the partial differential equation, which is contribute almost 20 to 25% of your final exam. Please go to the partial differential equation by your own. I'm going to describe in the class. Very simple. Don't worry. You just focus chapter 5. The basic is a chapter 5. For ordinary differential equation, also you need to spend 20% of your final exam, the last part, all right? Okay, and then your chapter 7 is contribute to around 50% of your final exam. Please, okay, study your self-determined learning by my material. You can see there are so many colors here, means that the color is a YouTube, the colors from the video that I upload. Okay, at the e-learning, you can download, you can listen, and then the PDF file, the notes, okay, based on my writing and my teaching from my mouth, all right. And then you can see here, all right, they are come very, very detailed about the Poisson equation of elliptic type, and then hyperbolic equation, all right, for the solution, all right. So I hope you can watch the video first, study by your own before we meet, okay, on the next lesson. This is a contribute to your final 25%, right? Very huge, all right? So now try to do a speed, active learning, self-determining learning, okay? Okay, and then we hope that you can find okay, for the next session. Okay, bye bye. Take care of yourself.